Yeah, to this expression. What I would like to do is replace all x's with r plus h. Small, I think. So this is what we want. All symbols are references, by the way. So that's why I put a reference everywhere. But for the, you can just look at them as variables, whatever. So we have error squared subs x is wanted to be error squared, a big formula, where you substitute x with r plus h. That's what I want. That it won't compile because subs does not exist yet. Okay, after that I'll print it. To see if it worked. So I want to call subs on error squared, which is something that is returned by this function, error squared, which is a symbolic expression. It's this class. I guess it's not that different from anything else that returns an expression. So something that's protected, which takes arcs. What the hell does this thing do? Get. It's a template. Look down here in the header. Here it is. Database in place, new T. So this constructs a T from those arguments. And, okay, what is T? T is the template parameter. Oh, it's just it's a static function where you can pass some type, and then it will construct a type. But it's protected, so it's really nothing for us to use. There's only one other expression here. Oh, here's another one. Return the get base. Get base return this. Nobody knows what that is. Or it's just a default for the virtual function. So it has to do with the exponent. Yeah, and derivative then, I guess. Okay, let's just go the virtual route. So virtual expression, const reference, and then substitutes. And yeah, let's just allow replacing. I was gonna say replace symbols, but why not allow replacing any arbitrary expression? Symbol is also an expression, isn't it? Yeah. Oops, sorry. So something like this, I guess. Okay, it's good derivative for inspiration. Arc tangents. Arc tangent. That must be a new expression, I think. Unless nothing is replaced. Maybe I should have this thing return an expression pointer and then return null pointer if nothing is replaced, so I can choose that. Then I don't know what to do. Maybe the arc tangent is not the easiest thing to begin with. I don't know what to do. This thing represents the arctangents of some argument. So if argument itself does not contain replace, then nothing changes. And I should definitely not create a new expression. Can also add a test that finds out if something contains something, but yeah, might as well use the whole subs immediately, no? So let's change this thing in a pointer to a pointer. But then I need to change the name, I think, because I want to use subs for the public API. How about we just write it full substitute. So then I can do new arc is arc dot substitute replace comma with, and then if not new arc, that means that there was arc does not contain replace. Then we don't have to do anything. And otherwise we return the arc tangents of, so there must be some A10. I suppose it has a realize then. Realize new argument. Let's have a look at arc tangents. Does not have a realize. Whether the argument is just hidden. Arguments inside unary operator. That is an argument here. Constructor. Yeah, it does have a realize here, thank God. So yeah, the thing has a realize, it's static, okay, we'll just use the unary operators realize then. Yeah, that's, that would work. Passing a const reference to the argument. So, what the hell? This should work. But realize probably returns a reference. I don't know, I should not return this. Well, no, not at this level. I should return null in this case. And then here we need to return the pointer. So I realized normally it returns a const reference. To an expression. So I can just take the pointer to that. And in this case return null pointer. Good. That does mean, however, that we need to use this in the base class. So this is now a star. This is a full substitute. And yeah, I wanted to use subs. Apparently the first of its kind. No, just put it here. That one's not virtual, and it does of course return a reference as it should. And it's called subs. And then we do expression, new expression, called substitute. Okay, does this make sense? So we made a virtual function substitute, which, if there is nothing to replace returns null. AKA, if it returned null, then this is null, so this is false. Then we return just whatever we had, because nothing had to be substituted. And otherwise, if it not returns null, that is a pointer to the new expression where the substitution has been taking place. So then we have to return this. That should work. Okay, now to add this to the header. So that arctangents has a derivative and now also substitute. And that is then an override final as well. And that same way we have to do everything else. Arctangents, the next one is constant. Oops. Yeah, so the constant. Well, unless the replace equals constant. So we need to be able to test if this expression reference replace equals this constant. Normally I would just compare this pointer with the pointer to replace. Do we have an equals? I think we do have an equals. Binary op equals expression other. Yeah, no, that's different, I think. It's probably not necessary. It's not really containing pointers, I think. For comparing pointers. But on the other hand, it seems like exactly what I do need. Yeah, kind of. So if this constant equals an expression, then it is the same constant, but not. No, not really. Actually, it's a constant with the same value. It could be a different constant. No, no, not not. Yeah, it would be really weird to replace a constant, I think. I mean, it's comparing it with the number and denominator. So just with the value. So say you want to have a half, you have an expression with a half, and you want to replace a half with a quarter. Then if I use equals, it would replace every one half in the expression with a quarter. That's not what you want, I think. You just want one specific. I don't know. Let's not use equals. I'll just compare if it points to the same object. So if replace equals this, then it is the same thing. Let's do unequal. So in that case we have return null pointer. So that's not the case, so we don't replace anything. Okay, there is nothing to replace. Okay, we return null pointer. And otherwise we return, yeah, just whatever we want to replace it with. Okay, what am I doing here? Oh, this is the header. Never mind. In that case, I have to add override. Why not also final? Don't think I derive anything from constant. So the thing marked as final in the declaration of the clause. No. Well, I think you can do that. You can just put final here or something. This one is marked final. This one is. This one is. And the derivative wasn't. I think it's weird. Well, they should probably just add a final to the clause itself then, which means that you can't derive anymore from it. I'm not sure where exactly. I think here or something. See if it still compiles like this. Allocating an object of abstract class log. Okay, yeah, that's can't test yet. If it compiles then. The next one is the cosine. Well, that's going to be very, very, very close to the tangents. Might as well copy that. And I need the same thing again for the sinus. Exponential. I'm just going to look for the sinus. Function, the log. Okay, log. Log is the same thing. Everything that's a unitary function. is a power unary function. Binary operator, so never mind then. Product sign. Okay. It's actually a bit of a bullshit what I'm doing here. Adding it to everything. I could just add it to the unary function. So undo all of this. Let's try to quit here, or right quit, or right quit. So I do not want to do the cosine here. And also not a log. Let's just disrealize here. No, this is so very much the same as constant. It either is the same thing or it is not. It's kind of the same as that one. If it is similar, you want to replace it, and otherwise there's nothing to replace. The thing it has to be, the way it has to be replaced is by returning with. Symbol is replaced. Let's try to do that the other way around. If this equals replace, return with. Function is doing difficult. Function. Let's see. Why? Substitute next derivative. Let's put it right here. Ja, so the function has a definition, apparently. And the name does not change, I think, does it? You just replace the definition here. Yep. So we need to apply the substitution on the definition of the function. You just have a name. Your last text and name in the new definition. That should work. And I'll maybe use it to tertiary thingy again. So it exists, we call this, and otherwise return null pointer. Non-pointer operand const function incompatible with null pointer. That's lame. Oh, wait a minute. I forgot. You have to take the pointer out to realize. And the next one is power. Or just all binary operations, I guess. Power. This is not what I wanted. Next. Power derivative. This thing must have a derivative. But I have a feeling that you just want to replace argument 1 and argument 2. That's the only thing you want to do. Which are part of binary operator. So let's do this in the base class. Arg1 and arg2. Yup. And that looks, or should look a lot like the unary operator thingy. Where I added it at the bottom. Substitute after equals. Substitute, replace with blah blah blah. So now we have two arguments. Argument 1 and 2. It's slightly more complex, so maybe I should just now do... Oh, wait a minute. I did do it like that. So an argument 1 and an argument 2. 1 and 2. Yep. Yeah. Okay, so if... Well, blah. I can do two tertiary thingies. It's slightly more complex, or is it not? No. If not, sorry. Yeah, bum. So if that one or that one, then something has to be replaced, otherwise you return null pointer. And then the realize function probably takes two arguments. Binary operator realize, argument 1, argument 2. So then we can do here, if new argument 1, then new argument 1, otherwise argument 1, comma, new argument 2, new argument 2, otherwise argument 2. Yep, perfect. And that should take care of all the binary operators. Oh, we have everything. Well, that means that maybe now we have a substitution or not. Wait a minute, what is this? I thought it compiled, but no. No viable conversion from const variable to const expression. Oh, that's just a current code where I try to use this. I have to use symbol X. Compile. Yep, compiled. In other words, now we can run this again. It should have fucking worked. So we have error squared, and then we have stuff times x. And then 3c1, c2x, and so on. And then here we have after the substitution. Times h plus 3, times h plus 3. All x's are replaced by h plus r. It's not canonical anymore though. But yeah, I think it's going to work. I think it's going to work. Then the next step is that I want to well, we can make a constructed Taylor series. Oh, that doesn't get any simpler then. What? No, really? Okay, now I'm confused. Oh, right, yeah. Let's see if Octave can do something with it. Is this? The paste didn't work. I don't know. It's not displaying Yeah, that's what I mean. The octave is not able to process large formulas like this. Oh, it is. Took a while. Yeah, so I want to expand this thing. See if that is working within a reasonable amount of time. It is being divided by something as well. I think it should be the fourth power of something. What are we dividing by? There's a plus here in the middle of my divide. So broken. That display is absolutely horrible. I am on. Ew. Takes forever. Just have to re-implement this in C++. An expand. Need to add an expand, apparently. Takes forever. Eventually it might print something, but how useful is that going to be? So I'll just quit. Damn it. Even quitting goes slow. I really don't like programs that don't quit quickly. What the hell is it doing? It doesn't make any sense. 1 or 2 R's? 1 R. Kripboekte. Python, yeah. Who the hell write something like this in Python? It has to be fast. That did it, okay. Or maybe it was killed before, but it didn't print anything and there was nothing left. It does, see, but even this one didn't work. Ridiculous. The problem is the negative exponents here everywhere. Let's look at this one. I believe that they are all the same. So if I can highlight this. Yes. So if we multiply the r squared with that expression, and then you kind of hope that all these things will be removed, right? I'm not totally convinced, however. That would work if it recognizes that expression inside is the same. I think then it will combine the exponents and then raise this thing to the power 0 and then make it 1 and then throw it out because you multiply with 1. Stuff like that. Let's try this. If it is, I could also do a substitution now I think about it. The substitute is with 1. But then I need a reference to that expression. Could be some digging before we find that. Well, actually it's 2 times and then we have it. So it's probably possible to just get the reference to this expression from the error squared expression. Yeah, let's try that. So I have blop blop. roots. This one substitution didn't really work. Let's comment that out for now. So I want to print something of error squared. Which you have to know what it is. I think I guess it's a product. I'm just guessing here. So is product, does it exist? It exists. Yeah, is product. Okay, so I think it's a product. What else could it be? Or maybe a sum actually. It's probably a sum. Yeah, it's a sum. Okay, I'm gonna do is sum then. To see if that is true. Yep, there's a sum. And then that means we can cast it to a sum. How does a casting work? Oh, maybe I should just dump database. Let's see how that prints stuff. Yeah, see, that prints the pointers to the expression. This might just work. That's called dump database. And that is static. Yeah. Dump database, just a function, so I can just call it. It's just symbolic. Not Cairo, you know. Oh. What the hell? That looks like something that is in a loop. It's printing the same thing over and over. Yep, this was not a loop. Wow. That's one big database. Something went wrong, that's for sure. So these are all all the possible expressions that were used while doing this calculation. That's quite a lot. And then I did see the highlight, but that has been scrolled off ages ago. Yeah, and then we would have gotten a pointer, but I need a pointer in the program, not afterwards. I'm kind of interested. This is kind of interesting though. I mean, this repeat. It looks like a bug. No, how can this take so long? It's not writing to the screen at all, just to a file. Stop already. I think it's done. Maybe that was the highlight. No, that is the highlight, but we need a highlight in the database dump. Here they are. Of course, we need just that expression. So you can search for it directly. Dat werk. Okay, and then of course I need expression inside the power. Let's remove the -4 and maybe even the bracket, the parentheses. Ho ho! It occurs a lot. And then I want this to happen after a semicolon. And there we are. That is the expression. Yeah, not completely sure that this pointer won't change, so still. However, you never know. I mean, it's pretty stable, I think. If you run a program again, then all those pointers are the same. It's my experience. Let's compare that value. But I'm gonna extract this from the expression in the program, I think. AKA edit the program on with the program to database. Not do that. Okay, it was a sum, so I can cast the thing to a sum then, right? Right. Symbolic sum const reference sum whatever is static cast. Yeah, sum is. So my sum contains the expression that I want, since it just highlights a lot of times here. And it being a sum, I can get, I think, argument. To get is one argument of the binary operator, just arg1. So we can just print arg1 again. It's probably the first one. I think it's gonna work. First argument of the sum. No, there it is. Sum. So this thing should be a product. So let's say we have to test it. Out. Here's product. Sum argument 1 is product. Yep. Okay, so we can cast it to a product. It's printed. That is, let's print the first argument, which is probably just 2 or something. Yeah, it's just 2. It's just this factor. So argument 2 is then that one, which is then a sum again. So plus here. No, wait a minute. Yeah, it's 2 times parenthesis opening. No, wait a minute. It's 2 times parenthesis opening. So 2 to the power minus 4 times. It's still a product. Of course, it's still a product. I don't know. It's hard to read this. It's just hard to read. Okay. I think it's still a product. Now we got the power. So this is going to be power, of course, and yeah, probably argument 1 over power. It probably is a power. So let's immediately continue with. Surprised it compiles, because suddenly I thought that maybe it was called base and exponent instead of argument 1. Yeah, it is. There it is. That's the thing that we do to the power -4. So I need I want to replace this with 1 and then see how the whole thing looks like. Subs, just subs. I don't know what I subs. We substitute this argument 1 with 1. It's never easy either. I have a cached 1 somewhere. Cached 1. Nope. Nope. That's probably a part of the class constant. It's called S cached 1. It did not work apparently. It totally did not work. Why? That's not make sense. Let's try something else. Let's multiply the thing with something. I'm taking r squared, and then I will multiply that with the thing that we found. Might work. Nope. Man, what the heck is this? It got big. Does not make sense. No. No. Totally not working. Okay, blah, fed up again. This guy is too strong. Oh shit. Sneaky. Yeah. Feels like you're playing against a computer. Very strong. Game over. Okay, I'm gonna stop again. Stream.